semiconductor devices. The question says that the common base DC current gain of a transistor is 0.967. So we have been given already the common base DC current gain. Common base DC current means alpha DC is given to us. So in our question we have been given alpha DC, and alpha DC is equal to 0.967. If the emitter current is 10 milliampere, so IE, that is the emitter current, is 10 milliampere. To convert milliampere to amperes, so that will be 10 into 10 raised to minus 3 ampere. Then what is the value of the base current? We need to find the value of base current, that is IB. So we have our formula for base current, that emitter current is equal to base current plus collector current. So from here I can find the base current will be equal to emitter current minus collector current. And emitter current is already given to us, but we have alpha DC. Now we have a relation for alpha DC. We have alpha DC is equal to collector current upon emitter current. So from here I can find collector current. So IC will be equal to alpha DC into IE. So just multiply these two. So IC will be equal to alpha DC is 0.967 multiplied by 10 into 10 raised to minus 3. So I can write this as IC equal to 9.67 into 10 raised to minus 3 ampere. So I have got IC, I have known with IE, I need to find IB. So IB will be equal to IE minus IC. IE is 10 into 10 raised to minus 3 minus IC value is 9.67 into 10 raised to minus 3. So if I take 10 raised to minus 3 common, I have left out with the 10 minus 9.67. So when I solve this, I get IB equal to 0.33 approximately into 10 raised to minus 3. That is my base current. Next question, in a common base connection, a certain transistor has an emitter current of 10 milliampere. So I have been given an emitter current, that is IE is given as 10 milliampere. So again convert it to ampere, 10 into 10 raised to minus 3 ampere. And the collector current of 9.8 milliampere. Collector current means IC, that is 9.8 milliampere. So that will become 9.8 into 10 raised to minus 3 ampere. Calculate the value of base current. Yeah. So this is very simple. So we know that emitter current is equal to base current plus collector current. So from here I can write base current will be equal to emitter current minus collector current. I know both the values, just subtract the two values. You get 0.2 into 10 raised to minus 3 ampere. Right? 10 minus 9.8 is 0.2. 0.2 into 10 raised to minus 3 ampere. Next, last question for the semiconductor device. We have only 3 numericals in this chapter. So this is the last question. In a common base connection, the emitter current is 6.28 milliampere. So I have been given the emitter current as IE is given 6.28 milliampere. So that is 6.28 into 10 raised to minus 3 ampere. This is given to me. And the collector current is given to me as 6.20 milliampere. So that is 6.20 into 10 raised to minus 3 ampere. Calculate the common base DC current gain. Common base DC current means alpha DC. I'm supposed to find. So we know that alpha DC is equal to IC upon IE. So value of IC we have already known in the question. IC, IE both value we know. 6.20 into 10 raised to minus 3 divided by 6.28 into 10 raised to minus 3. So these both will get cancelled and alpha will be equal to 0.987. Alpha DC will have no unit because IC and IE both are current having same unit, so unit will get cancelled. So it has no unit. So alpha DC is having no unit. Also, to remember students, alpha will always be less than 1. The value of alpha should always be less than 1. So please make sure that you do your calculation in such a way that you get alpha value always less than 1. Alpha will never be greater than 1.